Hello everyone. Let's look at today's Leetcode problem. 33341. Find minimum time to reach last room. Before starting this problem, let us look at the motivational quote for today. Success is the sum of small efforts repeated day in and day out. Written by Robert Collier. It is very true, right? So we always need to be consistent. We always need to uh, constantly keep challenging ourselves and also taking up new challenges so that we improve our problem solving skills. Let's look at the lead code problem. Let's take another example uh, where we have a array of 0, 5, 80, 90 and 20 and 3 and 2 comma 20 comma and 5 comma 10. So let's consider this as an example. Let's see how we can solve this. So if we are considering which is the nearest path, so let's say we go from 0th index to the first index, so we need to wait for 5 seconds and then we can move, which would give out 6 seconds. And since this is the shortest path, or since we are being too greedy here, let's call this a greedy approach. 6 seconds, and we are not choosing this path because this has a greater value. And so now let's say we go from this index to this index, so we might wait for from 0 1 to 0 2, then we have a 6 second, and then we need to wait for 80 seconds. So let's say we wait till our time reaches 80 seconds, and then we move to 81 seconds. So let's say we are at 0 2 at the 80th second, and then we want to move to the this cell which is at 20. We already have, so we can say we can add in a wait time of 1, and then we can call it, and we can simply move till here at 82. So this is the output that we get through greedy approach. And 1, 2, 1, 3 will give us 82 from greedy. While this is not the right answer, the answer to this problem lies in choosing this path where we go from this path to this path. This would be the most optimal solution, and this can be considered as a shortest path solution where uh, Dijkstra's algorithm is the way to go about it. So let's understand how we can solve this. Let's see how we can implement it through Dijkstra's algorithm. There is a dungeon with n, m rooms arranged as a grid. You are given a 2D array move time of size n, m, where move time of I, j represents the minimum time in seconds when you can start moving to the room. You can start from the room 0, 0 at time 0, and you can move to adjacent room. Moving between adjacent rooms takes exactly 1 second. Return the minimum time to reach n minus 1 m minus 1 room. Two rooms are adjacent if they share a common wall either horizontally or vertically. Okay, so there are few things to note here. One is there is a rooms of grid which is n comma n, and there is a move time array which is also n comma m, and a specific uh, cell in this array at a two-dimensional array is this I comma j. And you can start from the, so we always need to be starting from the index 0 comma 0, and another point that is to be noted here is at time is equals to 0, and to move to the next adjacent row we need to add t plus 1 second. We need to return minimum time to reach the. Let us look at an example. Let us take this example here. Uh, so let us look at this example where we have given 0 comma 4 and 4 comma 4. So this is the move time array, and one way of traversal to 2 comma 2, which is the length of the final index. So we can choose path either this path or we can either choose this path. In this problem, both of them will lead to the same. But let us look at how we can traverse to this. So if we need to move from 0, 0 to 0, 0, comma 1 or 1, comma 0, the time should be wait till 4, as it's of 4 value, and here also is of 4 value. So once we wait till 4, then we can move to either this one or this index. So moving to the adjacent cell, we need to add t plus 1 second. So considering this, so in order to reach 0 comma 1 or 1 comma 0, the time would be 4 plus 1. From either, in order to move from, let's say 0, 1 or 1 comma 0 to the last cell, that is 1 comma 1, which has a time of 4, and here we already have a time of 5 as calculated here. So we know that this is so we know that this time is already greater than the last cell, so we can say time 5 is sufficient to move to this cell and no wait time is needed. And in order to, and we just need to add 1 for so the total time that is required to travel. This is the total time. Okay. So we can consider this as a step 1 and this as a step 2 and this as a step 3. Okay, let's look at another problem, another example which is having to say 0, 0, 0, 1, and all of these values are again similar. So in order to travel from this index to this index, which is this 2 comma 3, we can choose either the path of this or we can choose this. So both might return the same because all of these values are similar. So let's see how we can do this. So at t is equals to 0, we are at 0 comma 0, and in order to either move to the next cell, which is 0 comma 1, then we would be having a time of plus 1, which is 0 plus 1, and this would be 1. And in step 2, if we need to move from 0 1 to 0 2, which is this final cell in the row, we would be needing t plus 1 again, which is this would be 1 plus 1 is 2, and the final cell, which is 1 comma 2. This is the 0 row and this 1 row, and this is the final column. We would be needing another 2 plus 1, which is 3, and this is the output that we see. And let's look at the final example 0 1 and 1 comma 2. Example 3 0 1 1 comma 2. So if we need to look into this one, so it would be 1 0 1 and 1 2. So traveling to the time required to travel from 0 to 1 comma 1, we would be needing, let's see what time we would be needing. So both of these are of same value, so we need to, for 0 0 to either 1 comma 0 1 or since both value is equal to 1, we can go to either of them, but we would be needing to wait for a second, wait for 1 second, and so let's say we go to 0 1 and let's we also need to moving time is equals to 1 second. So this will come out to time will be 2 seconds. So here we know that this has taken 2 seconds. So in order to move to the final cell, which is 1 comma 1, which has a weightage of time is equals to 2, the time is already we already have 2 seconds, so we only need to have a wait time. So wait time here is 1 second. So the output that we need to give is 2 plus 1, which is 3 seconds. And this is the output that we see. So let's look at the same example where we had 0, 20, and 5. So we can say this as a connected graph, and all of these are the possible directions where we can go. So what Dijkstra's algorithm says is uh, we need to find all the values or the shortest paths from this node to this node, and also the shortest paths to all of these nodes. So then we can uh, come up with the final solution, find all the shortest paths to each node. So let's say we are at this node, so we mark this as a visited node and this as a 0. And to travel to either the 0, 1, so we might be needing 5 initially, and let's say I mark it with a different color. So I will say 5 initially and 20 initially. And to travel to this node, then we might be needing 20 plus 20, and this takes 90. So let's say I take up this value as to travel to this node, we take as 20 plus 90, which comes out to 110, while this takes 85 and this takes 25, and traveling from here to here takes uh, 105 and 103, while here it takes 120 plus 103. So this part takes 123, while this takes 35 plus 3, 33. So all we are trying to do here is we are trying to say which is the shortest path. How can we go to each node or each cell in a grid or a graph problem where we want to find the distance to the shortest path. And to each node, and that's what Dijkstra's algorithm looks to solve. So let's use Dijkstra's algorithm to solve this problem. Let's go to the Leetcode. As you can see, the solution gets submitted. Please like and subscribe if you found this video helpful. One last thing, time and space complexity. Time complexity would be O of n into m, which is the array of the move times, and log of m into n. And while the space complexity would be m into n array that we are creating. Thank you. So firstly, let me have a set of variables which keeps track of the length, and another variable m which let's call these to m and n, and let's say we also create a another array to store all of these values, the best time to reach these values. So let's create a new array. And let's fill it with the largest number that we can fill. And let's also define the directions that we want the traversal to go with. So let's say we have -1, comma 0, and 1, comma 0, 0, comma 1. Let's say -1 to the left side and 0, comma 1 to the right side, and let's have all of these in a let's create a new helper function. Let's call this as a helper function where we give values of x, y, and some amount of time. Let's say current time. Let's say if x is equals to n minus 1 and y is equals to m minus 1, we simply return as we are at the last position or we have reached the goal, destination, final goal. Let's say we call this direction x, and let's look over each of the directions from the directions away. DIRS. Okay. And here we further calculate the values. Uh, and if nx is greater than or equal to 0 and ny is greater than and y. Let's set some boundary values. Let's say and y and x is less than n, then we want this if loop we from where we calculate the time needed. This is the current time plus 1 to traverse to the adjacent value, and we take map.max. We calculate the time value and we say if time needed is less than the value that we have in the best array, and best array of nx, ny, then we update the values in the array to time needed, and we continue to the next direction. We continue to the next direction using this helper method with the recursive call nx, ny and time needed. And we also need to set this initial or the starting point to 0 and 0. This time to 0 this at the start. And now we are good to try the solution. So let's call this helper method to start at the 0 time and 0 index and 0 time. And let's say we return the best value at the final index n minus 1 and n minus 1. So what we have done here is we have initialized the row value and column value, and we have created an array to store the best time that is needed, and we are using this directions array to travel to all 4 of the adjacent rooms, and we are checking this as a base condition if uh, we are in the nth or the last cell, and here we are having to move to the next directions and update the current time and the value in the best array. So that's what we are doing. Let's see if we can submit the solution and this works.